Today we're going to continue our discussion of polynomials by focusing specifically on binomials. Now, what are binomials and why do I care? Well, binomials are a very, very common form of polynomials that you see a whole lot in a variety of different types of problems. And they're usually the first real, introduction to polynomials that you'll see. You'll do a ton of things with binomials, from multiplying and dividing them to adding them and subtracting them. So first, what is a binomial? Well, the nomial part, again, means term. But this bi part means two. So a binomial is a polynomial with two terms. And if you remember back to the previous video, when I talked about terms, a term is a section of a polynomial that has, a coefficient and x raised to a certain power, or whatever variable. It could be 6z or 6y. It's a combination of a variable, right? A variable and a coefficient. And of course, you could have it to a different power, but that is what a term is. And so a binomial is a polynomial with two terms. So, for example, we could have one possible binomial we could have is 6x to the 4 minus 3x squared, or 7x cubed minus 8. These are all binomials. They all have two terms. And today we're going to deal with adding, subtracting, multiplying, and dividing binomials, which is a very important skill, because not only will you see it on a variety of assignments and tests, but it's a skill we'll build off of to eventually be able to do these types of operations with all sorts of polynomials. But since binomials are the easiest, we're going to work with them first. So let's start off with, let's say I want to add two binomials together. I want to add 6x to the 4 minus 6x cubed. I want to add that together with 9x to the 6 plus 8x to the 4. So the first thing I'm going to do is make sure that I find like terms, right? I want to find any terms where the exponents and the powers, they match, right? So there are two x to the 4s, so I know I'm going to have to do something with those. But for the rest of them, there's only one x to the 3, there's only one x to the 6. So I'm not going to be doing anything with those. I'm not going to be changing their coefficients, doing anything with them. So I'm going to actually rearrange them just as I would if this was, a full-out polynomial. So I'm going to rearrange them in order of decreasing exponents. So I'm going to start with the term with the highest exponent. The highest exponent is x to the 6. So I'm going to have 9x to the 6. And my next one is the x to the 4. So I'm actually going to keep these x to the 4s as they are. So 6x to the 4 plus 8x to the 4, just so we can keep them there until we're ready to do our operations. And then I find the last term, which is negative 6x to the 3. So I'm just going to put that right there at the end, right? So we go from the exponent with the greatest value down to the exponent with the least value. And that's the way we order polynomials. Now, for the actual simplification, we notice we have two x to the 4s, so we can combine them. We notice that we're adding them, and both are positive, so we can just add together the two coefficients. We can add together 6 plus 8, and then combine them with that x to the 4. So that looks like 9x to the 6 plus 6 plus 8 times x to the 4 minus 6x to the 3. Now 6 plus 8, that's 14. So in total we have 9x to the 6 plus 14x to the 4 minus 6x to the 3. And that's the final result that we get after adding together these two binomials. Now, what if we want to subtract them? What if this was a subtraction sign. What would our answer be? Now, subtraction is a little trickier because we aren't just subtracting individual term. We're subtracting all of this, the entire binomial in the parentheses. That means we have to take this -1, because this really is -1. We have to take this minus sign and apply it to both this term and to this term. So we want to rewrite our expression as a result. So we have 6x to the 4 minus 6x to the 3. Again, this part doesn't change. We're not subtracting this part. This is fine. But we're going to want to distribute that negative sign. So this becomes, that was a positive 9, now it becomes a negative 9x to the 6. This becomes a negative 8x to the 4. We're going to want to write it how we usually write polynomials in order of decreasing exponents. So this negative 9x to the 6 is going to come out in front, followed by the 2x to the 4s. It doesn't matter which one we put as long as we put them together. So 6x to the 4 minus 8x to the 4 in that final x to the 3. Now, once again, we see, hey, these two terms have the same variable, x, raised to the same power, 4. That means we can combine them. We notice we have a positive 6 and a negative 8. So when we're going to combine them, we're going to have 6 minus 8, right? Because we agree if we're adding a negative number, that's the same thing as subtracting a positive number. So we still get 6 minus 8, any way you write it, times x to the 4 minus 6x to the 3. Thankfully, we can simplify 6 minus 8 into -2 and attach that back into the x to the 4. So we have negative 9x to the 6 minus 2x to the 4 minus 6x to the 3. And there we've simplified our binomial expression down. So we subtracted two binomials. But what if we want to multiply them? What do we do if we want to multiply them? Because that seems pretty tricky. Let's go simpler. Let's have something like x plus 1 times 2x squared minus 5x. All right, and I'm told we want to multiply them together. Well, here we're going to use a special rule called the distributive property. That's where we take each term and we multiply it together with every other term once. I'll show you how it works. We're going to take this x. We're going to multiply it by this 2x squared. We're going to take this x. We're going to multiply it by negative 5x. We're going to take this 1. We're going to multiply it by 2x squared. We're going to take this 1. We're going to multiply it by negative 5x. That way, we multiplied every single term by every other term. Now that's a lot to keep track of. So let's start by writing this all down. So x times 2x to the squared. Well, that's we notice we have two variables we're multiplying together. They're the same variable. We'll notice that they both have exponents, so we can add their exponents together because we're multiplying by the same thing 3 times now, so it's going to be x cubed. I'm going to keep that 2 since that doesn't change. X times negative 5x, that's x times x, that's an x squared. Multiplied by negative 5, that's negative 5x squared. 1 times anything is that original value, so these things are not going to change. All right, but we're not done yet. We've distributed out our variables, but we haven't fully simplified them. We've always got to check to see if we simplified them. First, we say, okay, our polynomial is arranged correctly in order from the highest power down to the lowest power, so that's good. But we notice we have two x squared terms. So we can combine those two x squared terms. Let's do that. Right, so we can write that as -5. Right, this is a -5 plus 2 times x squared minus 5x. Right, so thankfully we know what -5 plus 2 is. That's really the same thing as 2 minus 5, which is itself -3. So we have 2x to the 3 minus 3x squared minus 5x. That is our fully simplified polynomial. So that's adding, subtracting, and multiplying binomials. I hope this helped clean that up for you and get you a solid understanding of how to use binomials and how to perform these types of operations on binomials. Because as we'll see in a bit, we can do a lot more with this. Thanks for watching. I hope you enjoy, and I hope you have a great day.